So again, my name is Zeki. I'm a PhD candidate at Karlsruhe Institute of Technology, Institute for Technology Assessment and Systems Analysis. And today I will talk about democratization of quantum technologies, which is a paper we published with Steven Umbrello, Christopher Koenen, and Peter Felmas. It is a collaboration between KIT and TU Delft. And you will also look up from Delft today. So there's an ongoing collaboration between our groups. And if you want to reach out to us regarding this paper, you can send me an email or Stephen an email through the list, through the email addresses that you see on the screen. And feel free to connect to me or Stephen through LinkedIn to ask your questions. And also I will be checking out the Discord channel afterwards, so please feel free to do so. I will be quick with the outline, so I will very briefly talk about quantum technologies. I think all of you know it, but still, for completeness sake, some background information, theories of democracy in different value contexts, a call for responsible quantum technologies, 3 narratives and counter-narratives, discussion, conclusion, and some advertisement. So this is the quantum technologies that, when I say quantum technologies, I'm referring to this. This is the European framework. In the US framework, there are 3 pillars: computation and simulation are combined. But in general, it is quantum communication, quantum computation, quantum simulation, quantum sensing, and metrology. And when we look at the number of academic articles and patents and patent families in the last 3 decades, or even 4 decades, we can see that since early 2000, there have been a rapid uptake on the number of published articles and the number of applied and granted patents. So we can say that this topic has been gaining some popularity. And when we look at the number of startups, we can see that in the last, especially 10 years, the number of new startups per year have been increasing rather rapidly. In the last couple of years, we can see some declines, but this is mainly due to the fact that it's hard to come up with data on recent startups. And when we look at the regional distributions on a global scale, we can see that there is no clear winner, so to speak, because there is a considerable proximity or the number of startups in different regions are rather close, although their sizes differ rather greatly. And when we look at the national initiatives and the amount of investments into these, we can see that there are many countries, many regional initiatives all around the world trying to develop quantum technologies, either locally or through international collaboration. And there's the estimate of more than 30 billion euros to be spent until 2030 on quantum technologies through public funding. So this is just for public initiatives. And of course, Julia very greatly mentioned this. We can see that since the last 10 years, there have been an increasing interest towards these technologies from more mainstream media as well, like Time and Science, although still the focus is on the science and the technology aspects. We can see that there has been some growing interest. And finally, of course, with the last year's Nobel Prize in physics, the field has been, so to speak, legitimized in the public's eye, and now we are, so to speak, a legitimate and up and coming science and technologies field with much promise. And this is why I think the quantum flagship marks the future as quantum. So what we did, so you can actually find our paper. It's published. It's on quantum science and technology. It's open access. You can go and check. And if you can't, for some reason, access it, I don't think that would happen. But you can send me a message or an email, or just write me on Discord, and I can share the paper with you. So what we did, we tried to contextualize what is actually understood and what can be understood with the term democratization of any technology, and particularly quantum technologies. And the idea that we tried to follow was, when we say democracy, we don't mean a single thing. There are different theories of democracy. And for this paper, we checked 3 theories of democracy that we think are they are the most mainstream ones: the deliberative democracy, participatory democracy, and representative democracy. And we also tried to put them in the value context, democracy as an instrumental or intrinsic value. And what we did was, after this theoretical framework, we identified 3 narratives that are kind of obstacles against democratization of quantum technologies, which are quantum technologies as an arena for geopolitics, quantum mechanics as incomprehensible, and quantum computing as a threat. And then we tried to come up with some counter narratives or just some mitigation methods. This is a table from the paper. You can find it. So what we tried to do is we listed these 3 democracy theories, and we tried to find or identify the differences in terms of the number of participants, the type of participation, participant selection methods, because these are usually decision-making mechanisms, and there are different aspects of decision-making mechanisms. And regarding the instrumental and intrinsic value distinctions in the context of different democracy theories, what we primarily argued is you can do the same things, like you can include stakeholders, but depending on your value context, the intention behind it is different. For example, you can include stakeholders for betterment of the deliberation process under a deliberative democracy framework, but you can also include stakeholders to support the technology development and or adoption. Or you can inform the stakeholders to empower them for them to better present and defend their position for deliberation. Or you can inform the stakeholders to reduce hesitancy towards the technology due to the uncertainty. So as you can see, you can be doing the same thing practically, but for different reasons, which would put your positioning with respect to your adoption of democracy as a value, either in the instrumental or intrinsic value context. I mean, it's entirely possible to define other value contexts, but for this paper, we tried to limit it to this, just 6 main, let's say sections, like 3 different democracy theories and 2 different value contexts. So what about the narratives? The first narrative is, I think, one that all of us are rather aware of. There is a quantum arms race going on that will transform the warfare. This is usually, it usually comes up with US and China. And sometimes Europe is also included there. We don't know why. But you can see that the context and the arguments of an arms race, a race, geopolitics, it's rather prevalent in the media. But also, how prevalent it is, we don't know. Julia had some wonderful ratios between different, newspapers and TEDx talks. But we can see it. So if you're in the field, you can at least understand that this is a narrative that is rather utilized for different purposes. And why is it being utilized? So in the paper, what we tried to do was, we didn't say, oh, these narratives are wrong, or these narratives are rather destructive, so we shouldn't use them. But we need to understand why these narratives are so powerful and rather widely used in the community and in the field, and how they're actually being an obstacle in front of the democratization efforts. And of course, this quantum technologies as an arena for geopolitics is rather understandable, considering that a lot of the early applications of quantum technologies are for defense and military purposes, and even the more benign ones have dual use purposes. And the second narrative that we kind of tried to explore was built upon this quote that if you think you understand quantum mechanics, you don't understand quantum mechanics. You can find it with many different background pictures and different photos of Feynman, all in the Google space, let's say. And when you do a Google search for this, you can see that there are more than 22 million results using one form or another form of this code. And of course, why? This doesn't come out of nowhere. There have been a considerable debate on the foundations of quantum mechanics and the philosophy of quantum mechanics, and can we even understand quantum mechanics? And I mean, anyone from the field knows the famous phrase "shut up and calculate," and the Bohr quote and the Mermin discussion. So there is this issue of how to make quantum mechanics understandable and comprehensible in the field. And finally, there's this issue of a quantum computing threat, the quantum apocalypse, the existential threat to our data encryption, and why is it rather prevalent? Of course, the starting shot of this quantum computing race, so to speak, was given by Peter Shor, Shor's algorithm, and the following discussions on whether Shor's algorithm can break RSA in 10 years, 15 years, 30 years, in how much time. And we can see that even today, or let's say even mid-2010s, people were expecting that Shor's algorithm will be able to be implemented for rather useful, and by useful I mean for intelligence purposes or for cybersecurity purposes in 15 to 20 or at worst in 30 years. So this is a real threat that is being perceived by stakeholders. So I will just digress a little bit and then return back to these narratives. When we say responsible quantum technologies, what do we mean? Ethics or responsibility, responsible technology development, does it really make a difference? What are path dependencies, and some examples from quantum technologies? So this is a slide from one of our doctorate modules in ETAS. When we say responsible technology development, what we're trying to target is, we assume that there are some technology enthusiasts saying that, oh, don't worry, be happy, innovations will solve every problem. There will be no, climate change. There will be no hunger. There will be no poverty in the future because technology, yeah, it will save us. On the other hand, there are those that highly focus on the limits and risks and potential damage that can be caused by technologies, and they're more worried than happy. And they practically say that there needs to be some, mitigation methods, and we should only introduce innovations to the market if we know that there are no potential damage whatsoever. And the responsible technology development mindset is basically sits in some place between, because there are potential harms and potential damage, but also there are some considerable potential advantages for these new technologies. So we shouldn't just say that oh, if there's any potential harm, we shouldn't do it, or if there are potential advantages, we should definitely do it without looking at the harms and damage. One example of this mindset is seatbelts. The first car was introduced in 1894, but it took more than, or let's say nearly 100 years for seatbelts wearing law came into force, especially in the UK. And even by then, it was opposed by the Conservative government and the Labour official opposition. When we think about cars and seatbelts today, it's so, we don't even think about it, that it only makes sense. But this wasn't the case for more than 100 years. And this is technically, or we can argue that it is technically due to this concept of path dependency, which basically means that the earlier decisions contribute to the later, design options, and they act as constraints. And sometimes there are lock-ins. For example, why our trains are of this size. It goes back to the 18th century horse-drawn wagons, and it goes even back to the Roman roads. And similarly, why are we using this kind of a keyboard instead of this? Because this is rather inefficient, but it goes back to the idea of having physical typewriters, and they get jammed, and those kind of historicities. There's a okay. And two examples from the field of quantum technologies. One is Quantum Energy Initiative. I would strongly recommend you to go and check their website. The idea is, we are developing these devices. All right, they can solve a lot of things, but what about their energy consumption? We assumed that quantum computers would be much more energy efficient compared to their, supercomputing counterparts, but this may not be the case because of quantum error correction and the way we implement error correction today, or way we envision the implementation of quantum error correction. It will be very energy intensive, so there might be some issues with it, and we need to address them now. And similarly, the second example of path dependency that we can discuss is quantum ethics projects. There are many programs being created from scratch today in quantum science and technology fields. And if we don't integrate kind of an ethics or societal approach to the syllabi right now, it would rather be difficult in the future. And you can see this is from, I think, Maninders and Aras's paper on development of a quantum workforce. There are many master's programs around the globe, and I think there will be many others on this list today. So what can we learn from these practical examples? So what will be the energy consumption of future error-corrected quantum computers? What will the future quantum engineers learn during their master's or PhD degrees? And when is the time to discuss this? What is the appropriate venue, and who gets to discuss and why? So these are all questions that we can discuss, and those should be discussed. Or at least those questions are the ones that we believe that should be discussed. And regarding the narratives, so the three narratives we discussed in the paper are quantum technology is an arena for geopolitics, quantum mechanics is incomprehensible, and quantum computing as a threat. And we believe that overemphasizing these narratives create and or strengthen exclusionary practices and result in visionary lacking mechanisms often argued on the grounds of being fast. We need to be fast because of our, the US folks say that they need to be fast because of China. The Chinese folks say that they need to be fast because of US. The European folks say that we need to be fast because of China and US. And visions of the future and demands of certain stakeholders are prioritized, while the visions and demands from other stakeholders are suppressed. If this is a national security issue, or if this is a, depending on your funders, a finance issue, then of course you will prioritize their demands and their visions compared to some other stakeholders in the community or in society in general. And these path dependencies and rush decisions have their associated costs too. And one example is this Huawei 5G decision. In the UK, Huawei had this rather extensive 5G network, but then the UK government decided to just remove them, and it just costs up to £2 billion just to remove them and to replace them in the following years. And this is because of some national security threats, but this is clearly an example of how earlier decisions might lead to some unforeseen costs in the future. So some alternatives. You can see that the ones that we propose, they are not exactly on just getting rid of the narratives altogether, but for example, we can accept that the world consists of more than just hegemony powers and avoid protectionism, or let's say overprotectionism. And there can be a focus on civilian uses related to, for example, sustainable development goals. We should use famous code only in its proper context and not to implicate that people cannot understand quantum mechanics. And the quantum technologies need to become a normalized or even mundane technology, and pseudoscientific approaches should be criticized, like Michio Kaku's recent book. And we should focus on ways to constructively deal with threats, present realistic timelines. So this is I think one of the last slides. We should have a clear understanding of in which context the term democratization is located and used by different actors. there can be a phasing out of some narratives and replacing them with more constructive ones. And just providing access to either the technology or the products is not necessarily called democratization, because it does not guarantee agency. But it's a necessary but not a sufficient condition. So there needs to be some stakeholder engagement and empowerment. I would strongly recommend you to check Quantum Delta NL's Center for Quantum and Society. And if you are interested in this responsible quantum technologies approach, you should check our website at ETAS, or just reach out to me. The recordings are on YouTube, and we will have a follow-up event in the 27th and 28th of July in Karlsruhe, Germany. So I would like to thank you.
Thank you very much.
Thank you. So I see a question. Can I take a screenshot? So those are, you can find them in our paper. So you don't need to take a screenshot, but I can share the paper on the Discord channel as well, so that you don't have to Google it yourself.
There's also the question in what respect is quantum ethics different from general science technology ethics?
That's a good question. In the field, we are actually discussing this. What is actually different than other ethical questions, and a lot of them, a lot of the topics and a lot of the issues are the same, but there are some quantum specific topics. Like when we are talking about explainability for AI, quantum machine learning operates on a different, technical infrastructure, both in terms of software infrastructure and hardware infrastructure, which means that there needs to be a tailor-made discussion on how explainability for quantum systems operate versus explainability for AI systems operate. So this is just an example. This is Elijah Perrier's argument, and I would strongly recommend you to go and read his paper on ethical quantum computing. There are of course many other discussions, especially on the issue of geopolitics. There is this extensive use of arguments from geopolitics to fund quantum technologies, which is I think it's very field specific. We don't see that much of emphasis on this geopolitical race in other fields. Maybe recently on semiconductor industry, but it has been around for more than 60 years. So